Hello, and welcome to Data and Analytics Week of Devtoberfest. My name is Vitaly Rudnitsky, and I am one of SAP developer advocates who actually is the host of this week. This week started with two great presentations on the topic of demystifying data science in the enterprise and the modern enterprise data landscape. If you missed this session, they are available on YouTube for you to watch whenever time permits. And one more session from today morning that was presented by Truly Yours on the topic of data visualization. Yesterday was the day of meeting authors of SAP Data and Analytics books. So we had two panels, great discussions. If you missed them, then please watch replies as well. And now we are coming to one more panel, this time discussing with our experts how it looks like to manage and to run projects with data science in practice. But before we switch to that, I just would like to remind that tomorrow we have our Fun Friday activity. And this Friday, it will be all about coding for kids. So if you are truly into the topic, how to make our kids better in science, technology, engineering, and math, then please join this live discussion that we are going to have tomorrow. And there are two sessions available. So depending on your time zone, you can join any of them or ideally both. And with that, let us move back to our today's expert. And I would like them to introduce themselves in alphabetical order by their last names.
All right, I think I have to start. Hi, everyone. My name is Sarah Detzler, and as you can see, I'm competence lead for data science and machine learning in our custom advisory organization. I have now the job that I dreamed of since I was a little girl. I travel around Germany at the moment virtually and can talk about math all the time and can support our customers to put their machine learning and data science models into production.
Good.
Then that would be me. The next, that's Andreas. Hello, everyone. So Andreas Forster. I'm I tend to call myself a machine learning expert, enthusiast, or data scientist. I think the names are very much interchangeably for these titles. But in SAP, I work for our Global Center of Excellence for Data Value, where we're a team of with a lot of data scientists spread around the world, where we sort of do our best to help adoption of advanced technologies at our customers. And that can take many different roles. That could be business development engagement, that could be proof of concepts, working on customer requirements, or it might be maybe customers having licenses and helping them to get started. So quite a broad range. I can only concur what Sarah said. To me, it's a dream job. It feels like I can do machine learning day in, day out, and I get paid for it. So that's absolutely fantastic and enjoyable. Yeah. With that, over to Karthik.
Hey, thank you. Hello, everyone. I'm Karthik. I'm Karthik Muthuswamy. I work as a senior AI scientist for the AI business services team here in Waldorf. Like Sarah and like Andreas, basically, I also get paid for going around Germany and also around the world to, at least before, to teach people about data science, about machine learning, and generally about math, and geek out about statistics and things like that. But yeah, it's actually quite a fun job, trying to talk to people to make them understand and to also discuss about various aspects of machine learning, and then have one understanding of what the businesses do.
Perfect. And it sounds like indeed every one of you is enjoying this job. So first question, because this is something that was presented on Tuesday by colleagues from Deep Learning Center of Excellence, is that part of their job is playing computer games, Mario Kart in this case. So is it what drives you? Is it because like you spend half of your time just playing video games? Karthik?
As a kid, yes. But But I think growing up as well, yeah, probably a lot of time playing video games and then spending a lot more time with a computer once it was available to me in high school as well. But yeah, this was what actually drives me to also, really get excited about topics around computer science and in general about math as well.
Okay. Sarah, do you play?
Yes, I have to admit, I still play video games. Yeah, quite a lot. Big fan of Mario Kart. Yeah. Yeah, but for me, yeah, really, since I'm 6 years old, I fell totally in love with math and physics. So I knew at this age, that's what I'm going to study. At this time, no one was talking about data science, but when I then went to university, I thought, yeah, that's pretty interesting. Also optimization and so on. And then when I started at SAP, it came up with data science and machine learning. That's basically how I entered the field. Yeah, it was just the love for mathematics, statistics. Yeah, and that is still driving me.
Cool. Andreas, now I need to ask you, do you play computer games?
I used to play more in my younger days than now. Maybe a different generation, but I started on Commodore playing Pit Stop 1 and 2, like sort of Formula 1 race, but nothing comparable to Mario Kart, what Manuel was showing on Tuesday. And my niece and nephew that just introduced me to Fortnite, so I gave that a go, but I was quite useless. So any machine learning help there would help me along, yeah, to stay alive longer.
I see. So it sounds like, yes, to some extent, computer games helped you to get into this whole world of computers. But now a little bit more serious question. So how did you get into specifically data science? And actually, at the time you got into data science, was it even called data science? So Andreas, maybe we can continue with you.
Mm-hmm. Yeah, sure. So my history, I think, goes back to really reporting or business intelligence, as it was called at the time. So maybe about 20 years ago, really looking at business intelligence, which really was more like interactive reporting, drillable reports. So helpful, but not extremely intelligent. And then sort of in my jobs, I just continued through data warehousing, data quality. So always sort of extending the reach of what could be done with the data. And then at some point, this whole new world came along, which at the time, I think it was called predictive analysis, and still sort of heavy statistics approach. And at first, it seemed like a huge mountain. You'd never understand, totally different language, it seemed, but it was absolutely so fascinating what could be done. And then sort of with little steps, I got a little deeper into it bit by bit. First doing R, really, that was the language I started with. And then more and more sort of switching to Python. And then for a while, I tried to do both, but I got completely confused. And then the most simple command in R I couldn't do because I was thinking the Python terminology and vice versa. And so for now, I'm really sort of trying to stick to Python wherever possible. That's pretty much my history.
Okay. And Karthik, how did you get into data science or whatever it was called at that time?
Yeah, that's for me, data science, or back then it was called applied statistics or machine learning in its pure sense back in grad school. This was not too long ago, though. So, of course, if you think about it, if I think about it, it's about still maybe 10 years ago. But yeah, so it definitely wasn't called data science, and different parts of it were called differently. So we had, like Andreas mentioned, like visualization was completely separate. Data exploration, business intelligence was, I think, the most likely term as well. But my grad school thesis topic was also around machine learning and more about applied statistics as well. So this was predominantly, so this is how I also got introduced to I wouldn't call it data science, but now that I think about it, we call this umbrella term data science as well. And then that also got me, hooked into what we call machine learning and AI these days. But yeah.
Okay. Sarah, and how was it called when you joined?
Yeah, when I joined, I remember a lot of things we called then computer vision. Yeah, I think now we would also call it deep learning and image recognition, part of machine learning. But I come more from the optimization part. Yeah, so we're just talking about optimization algorithms and didn't embed that into our data science and machine learning part at the beginning. But then more and more data science was coming up. Yeah, and this is then how I slowly also got into that direction. Yeah, yeah, Andreas, you probably remember a few years ago we worked together. Yeah, regarding the topic predictive analytics. Yeah, it's also how we met the first time. Yeah, so it was pretty nice, yeah, to get started there with you. Yeah,
absolutely. It's nice to see how it all evolved, really. So from what SAP started out with individual tools, and then sort of branching out into automated machine learning, and how now there's really such a crucial part in the machine learning, well, in the HANA world, in the business technology platform. So it's really nice to see how it grew and got adopted. Yeah, and really all of it is a team aspect. So none of us work on their own. Currently, no, we're more remote than previously, of course. but at the end, no data scientists at SAP is working on their own. It's all a huge team collaboration. It's always good to have people to support with. Yeah.
Sure. And actually, data science is such a hype, or has been such a hype during recent years, that it felt like it always existed. And then completely by accident, I ran on LinkedIn today in the table that was called the hottest skills of 2015 on LinkedIn Global. And number 2 was statistical analysis and data mining, right? So it's actually not that long ago when data science didn't even exist.
Yeah.
Okay, we will have hopefully questions from the audience, and we ask like we are asking you to ask questions when you have to our experts. But if there are none, I will be continuing with my questions, because I prepared quite a long list. Once again, just everyone watching this live, please feel free to ask your question or your comment, or put your comment in the chat. And the next question, now going a little bit deeper into what indeed you guys are doing at SAP. If you could give an example of some recent project or engagement with the customer where you're working on something AI, ML, data science related. And Sarah, if I may ask you first.
Sure. I don't have one specific project. I just wanted to talk about something that was this year pretty in fashion. We have an SAP Analytics Cloud. We have a new feature called predictive planning. And this is something which is really, really popular at the moment with our customers. Yeah, because they all want to improve their planning. They all want to improve their business KPIs, their financial planning, and so on. Sometimes also HR planning. So there are a lot of things coming up in basically every line of business. And the cool part here is you have everything integrated in SAP Analytics Cloud, and just with a few clicks, you can do your own predictions, even as a planner, as a controller, as a business user. And this is something which is really, really popular, because I also feel there's a need for our business users, and not only for our data scientists, to get access to such predictions. And even though I'm a big fan of R and Python and I love to code myself, I really appreciate that we can also support the business users to get access to make their own predictions.
Yeah, actually, even yesterday during our panel with authors, these predictive capabilities in SAP, predictive planning capabilities in SAP Analytics Cloud were mentioned as something really cool, indeed. Thank you, Sarah. Karthik, what are you working on these days?
We actually currently working on a very interesting topic on the AI core. So we are working on so SAP releases AI core, which is now the base infrastructure for us to actually build machine learning pipelines and maintain machine learning pipelines, typically the MLOps as it's called. A very interesting use case that actually came up when we were discussing, how do or when do we have AI, when do we leverage AI core versus when do we use AI business services, was when we were actually speaking to one of our customers, and then they were talking about their business problem, and then we realized that we could combine both of this. So this was actually a very interesting use case where you could then leverage the first part with AI business services, one of the AI business service, and then build the customer could then build their second part completely customized on AI core, and then together they could orchestrate the entire pipeline on AI core. So they could then have this as well in the end, and then have a completely working productive endpoint that they could then use for their application. And this was really interesting because they don't have to do anything besides the fact that we need to understand the business concepts, the business problem, and then we have different services that could immediately solve that. And then something which is pretty customized for that particular customer, you could build it on AI Core, and then you have a productive end-to-end sort of this endpoint that the customer can then leverage and then build into their business application, which was really interesting. And probably if you're interested as well, there is also a Ticket session next week or in a couple of weeks from now on how to also use this AI Core. I think that'll be also more details shared there.
Interesting. And before we go to Andreas, actually, I need to ask you about one term that you mentioned, because I see this term kind of like hyping recently, MLOps. What is MLOps?
So MLOps is everything, all these basically the allied activities that you do as in, so we are talking about machine learning, model development, pretty much, you deploy it and then forget. Generally, I think people realize that, or basically people think that as soon as you have the best performing model, pretty much, everything is done, you can then put it and then go to sleep. But generally, this is where everything actually also starts, talking about a business problem, right? Business application has to consume this. Now, there is also a lot more things about what happens if there are too many, requests coming in. How do you scale up? How do you scale down? So what happens, say, for example, when this is a season right now, and then, then you have to scale up to maybe millions of users coming in, or probably during, at nights, there is nobody using your machine learning model, and there is no point in actually serving anyone. How do you scale up, scale down? So all the allied activities related to how do you, maintain, how do you manage your model as soon as it's deployed to a productive endpoint, you actually then have to deal with all of this, these things which then come under this MLOps terminology. And I believe there are really good also courses that actually talk to you about, if you're interested, you could take these courses, which could give you a much better, broader perspective on what exactly MLOps actually come into, to help the team as well.
And guys, I will be kind of like asking questions like this during this this session, because I ran the poll in the chat, and actually 86% of people do not have anything with data science so far, right? So even though I understand that you might leave MLOps day in and day out, and it is something completely obvious for you, it might not be that obvious for our audience. So then I will ask you to clarify. I hope that you don't mind. Andreas, so I hope that you still remember the question. The question is just like any interesting example of the projects that you've been doing with customers recently.
Yeah, absolutely. So currently, I'm almost in between sort of two specific customer engagements and proof of concepts that I can speak about, where one that's just winding down is with a company that is providing a health app for people to install on the phone. And this company wants to help people to live a sort of healthier lifestyles. Mm-hmm. And as part of that, they want to achieve, they call it hyper-personalization. So to give a very specific personalized recommendation to their members, to the people on recommendations, maybe on articles that they have written, or suggestions for sports activities. So very, very comprehensive. And the app is still fairly new. It is live, and they started to collect data. But so far, the data they're collecting is very much operational, just for the applications to run. And they don't really have yet a very holistic overview of the individual people and sort of how people, are actually sort of behaving overall. And in that proof of concept, we use the business technology platform to collect that data, bring it together in the cloud. For that initial step, that would be done with data intelligence, store it in HANA Cloud, and then start, first of all, to prepare a view of individual people. How often did they exercise? How long? What was the distance? How many articles have they read? And once sort of that view is there, and that's very often really the first step of a data science project, to get the data, prepare the data, and then we started really to analyze. And the approach we took was, so far not a lot of data is available. The approach we took was around customer segmentation, all data driven through clustering. What kind of people behave similarly, and what makes them similar based on the data evidence, and sort of to see how people transition through these clusters. Now, have they been super sportive all along, or did they just transition from a more passive to a more active person? And that is the first step now to provide some personalized content to the members. And as the system grows, this can be much more tailored down to specific recommendations for individual people, what kind of content, that they might be interested in. So there's one proof of concept that's coming to an end, and maybe I can talk about the next one. That's
Sure, please.
Yeah, because it's actually sort of almost quite similar, even though it's a very, very different use case, where we use the same tools still to collect data to come up finally with predictions. But there it's not a B2C, but it's a B2B environment where we are talking to a chemicals manufacturer who wants to improve the quality of their manufactured batches. Are they in specs of good quality or out of spec of bad quality? And what are the drivers that sort of imply or that might lead to batches that are not of the desired quality? And here, very often, sort of manufacturing companies, of course, they already do a lot of statistical processing, a lot of analysis, not always in real time, but often quite isolated, that they might only look at sensor data from the shop floor, from the manufacturing plant, or one company said it took them 4 months to collect all data from the shop floor, the sensor data from the machines, join it with other sources, ERP, human resources data. So massive project for them. And here now we're using the same business technology platform, the same data intelligence, the same HANA cloud, the same data warehouse cloud possibly, to bring that data together, to get that holistic view of sensor data of what is happening right now in real time, joined up with information from the ERP system. In that case, I don't think it's even in S4, I think it's in ECC, sort of to see what is currently being manufactured, what are the raw materials that went in, to then sort of highly automatically come up with a prediction, not just of is it good or bad quality, but while it's being manufactured, what currently is the driver that has the highest correlation to out of spec quality, giving suggestions to the engineers at the plant, so to act before it's too late, keeping everything in sync and in spec. And that's often the joy that I see, and maybe it goes a little to what Karthik said, combining different tools, different components for more comprehensive use cases, and the more you add to it, and suddenly becomes sort of even more interesting and more value. And often it's really the combination I find where you need some experience in machine learning, data science, but also a lot of experience about the actual business process that you try to improve. And if that know-how comes together, and often that's one of these aspects where you need multiple people. Usually it's not one person, but you come together, you then understand the business process, give an understanding of what machine learning can do, then it gets so interesting. And that's the part of machine learning projects where you start with a vision and then you have to try it out. You never know what kind of pattern you find. And so we're hoping, of course, now that we're able to find a good predictive model, a good pattern. But upfront, no, that is an unknown, and that is part of the mystery and the excitement, I guess, that we're enjoying so much.
Yeah, actually, this unknown is quite often coming in any discussion, like how do you compare data science, machine learning to regular, let's say, software engineering, right? Where in software engineering, you are starting with the vision of what you are going to build at the end, right? And then you just like code and develop solution toward this goal. In machine learning, it often starts just like, so what is this unknown that we are going to address at the end? Actually, we do have questions coming in chat, but before we switch to that, just follow-up question, because Andreas and you others, you were mentioning different phases of machine learning project, and then everyone is usually think that data scientists just sit the whole day and just building this next cool machine learning model. But what is the reality? Like, you mentioned different phases: business requirement gathering, data collection, building this model, going to production, keeping machine learning models running. Where do you spend most of your time? So Andreas, let's start with you. And
mm-hmm. Yeah, sure. So I wish it would just be machine learning and just scripting and getting stuff to work, look into the numbers. But reality is, I think across projects, SAP, non-SAP, it is getting access to the data, for example, we can't do comprehensive machine learning, or there's a limit of what you can do in an operational system. So often, you work with data that has been replicated somewhere potentially. And how do you replicate the data? How do you structure the data? Because the raw data is not the data typically that is fed into a machine learning project. You have to aggregate the data very often. If I come back to the manufacturing batches of a chemical company, all that sensor data, all the data from ERP systems, in the end, as first step, we intend to aggregate down to individual batches that were being manufactured. And that could mean that thousands of sensor data get aggregated to one row of data. What was the maximum temperature? What was the vibration on average? Or so what was the time the temperature was over 120 degrees for that individual batch? And or how did the temperature change from that really goes down to data preparation, which really is, in my cases, the majority of the work that I spend on.
Okay. Sarah, is it different for you, or data preparation is where you spend most of your time as well?
No, it's actually pretty similar. The same data preparation, data cleaning. Yeah, it's most of the work. And something which is also really challenging is goes also into the direction of the MLOps, is that we put them into production. Yeah. Properly and also in a sustainable way, because as a data scientist, you not always have just one model that you have to take care of. It's quite quick that you get 50 or sometimes 100 models that you should take care of, and then you make sure that you check them on a regular basis if they're good enough. Yeah, and you also have to retrain on them on a regular basis if they still fit to the business needs, if they still fit to the new data and all the other requirements that are changing. Yeah, and this can be really time consuming if you don't do this in a proper way. Yeah, so it's always good to think about to check this automatically on a regular basis, your models, retrain them automatically on a regular basis, so that you as a data scientist here get involved at the minimum. Yeah, sometimes you have to get involved, of course. Sometimes you also have to tweak the algorithms a bit more. You have to maybe extend the algorithm, use a different algorithm or things like this. Yeah, but you have to really put this down to a minimum, because otherwise you will be doing nothing else than just taking care of the models you already developed. And of course you want to do the cool new stuff. Yeah, you want to have more fun with the newer projects.
Sure.
So,
Karthik, and how about you?
Yeah, I think I will only agree with Andreas and Sarah. But besides that, some of the things that I also adding to what they also mentioned was that in general, we also have to understand the business problem. So first of all, understanding if machine learning is required. So most of the times, there's also this point that we have machine learning. So if you have a hammer, everything looks like a nail to you. So in general, when you see machine learning, everybody wants to use it. But in general, we also have to understand or make the customer understand if machine learning is required for their business problem, to also convince them that in some cases machine learning might not even be required, that they could actually solve their problems with simple rules. This is also one of the responsibilities as a data scientist. One of the other things that I also do is also explain the do's and don'ts of data, what they can do and they shouldn't be doing with the data that they actually bring in, because invariably there are lots of misconceptions about how to train a machine learning model or a deep learning model. And then this is also something that data scientists, as in I, also end up sometime or most of the time doing.
Okay. Thank you. And we will start with you then with the question that we got in chat from a person with the nick Zeitiger. I don't know if this last name or just a nick, but the question is a big problem of AI ML is that data often contain discriminatory parts, and as a result, forecast and decision reproduce discrimination. What is the state-of-the-art process to prevent that? Are you dealing with any of these issues? Like I assume it is about the bias in the data and in the model.
So in general, maybe I can quickly add my perspective here. In general, when it comes to bias, I think the onus responsibility lies with the person who is trying to, train this system as well, because invariably they are the ones who actually have the best understanding of what is a bias here. But in also we also have systems right now, for example, on like I just mentioned earlier. In AI Launchpad or AI Core, we will will be also integrating in the future some explainability aspects, which will also give you, how is your data, how does it look like, if there is potential bias in your data in terms of if there's a skew in the data distribution, so on. And also, so this is one aspect of the bias, but of course, when it comes to, say, a language, that might be a completely different aspect of dealing with. How do you, think about handling that is something that you have to also, you have to take care of that separately. Besides, not just depend on these automated systems, but rather as a human being, as a labeler who brings in the data, the responsibility lies with that particular person who's going to train the system.
Okay, thank you, Karthik. Sarah, do you have any experience with bias in the data and how to handle it?
Yeah, it can happen. Yeah, and I see it also as Karthik. It's pretty important that you also have a look at the explainability of your models, that you don't trust them blindly. And what I'm always doing is that I also check the influencing factors. Yeah, of course, we can exclude some things from the data, like, for example, the gender or the age would be typical things that would lead to such a bias, so we can exclude them. Or what we can also do, that we check the influencing factors and we see that age has an influence or the gender has an influence on a certain variable, then we see, okay, our data is biased. Yeah, so that at the beginning we are aware of it. So then the business user can also do something about it, and we can learn something about it for the future. So we can really, as human beings, reflect about it. Yeah, and then of course we will exclude these variables again, but sometimes it's not that easy. Yeah, that you not see it in such straight cases as we would have it in this example. Yeah, but still here, when you have an explainable AI, you can do a lot of things there. Yeah, and sometimes even if it's more hidden, you can then still reflect, check with the business, ask them what is happening here, how can we improve it, how can we make it more bias-free, yeah, in our model and also in our business processes.
I see.
And just adding to that, because that's also one of the examples where a machine learning project is not implemented and completed, but it's really an ongoing process, and that involves the MLOps. Now that model gets retrained and is available at the latest sort of best quality, to the business process, but also that the model as it was created needs that validation of, specifically in that B2C environment, where the discrimination could be an issue, to really verify what is reality, what did the model predict. And so it's very different to maybe creating a dashboard where at first you gather requirements, you implement, and then sort of test and validate that it works, where then you could consider it sort of complete to some extent before the next modification comes along. But machine learning there is a very, very different approach.
I see. So far we were talking about, let's say, your involvement as to a big extent technology or technical people, but as well we mentioned that there is always business involved and business users involved. So how can business users and developers work together when working on a project that involves machine learning? Sarah, can I start with you?
Yeah, sure. And yeah, in basically all the projects we've been working together. Yeah, we had IT developers, data scientists, but also the business users. And they're really, really important, especially at the beginning. Yeah, because the business users are the ones that have to use it in the end. They have to trust the model. They have to know what happens. We have to make sure it's integrated into their tools, into their business processes, so they can use it. Because let's be honest, the best model is useless when no one will use it. Yeah, so that's why they tell us what their requirements are, what they want to achieve, also how good the model has to be so that it has to bring some value. And then we as data scientists, we try to understand where they are coming from, on what their goals are. Yeah, and then during the entire process, of course, we do most of the time the coding and so on, we check on a regular basis with the business and see, does that still fit to your requirements? Would it be something you would be happy to use? We also try to explain them what happens in the background. Yeah, and sometimes you also discuss with them what kind of algorithm to choose. Sometimes it's better to choose an algorithms which they can understand and where we can see the influencing factors and know what is happening, so they trust it and then they can use it. Yeah, so this is really, really important that they actually involved from the beginning to the end. Sometimes I feel like I have to be the translator from the business to the data scientist and back and forth. Yeah, but that's still fun. And yeah, it always worked pretty well. Yeah, when you start engaging them from the beginning till the end.
And before we move to Andreas and Karthik with the same question, just because you mentioned selecting the algorithm. So is it always that like data science team is pushing for the latest and greatest and the most fancy deep learning, neural network algorithm? Or how does it look like with selection of this algorithm?
Yeah, that is true. I have a lot of colleagues who are always going for, yeah, we need a neural network. And then the first thing I tell them, okay, why? Yeah, why do we need it? I'm no offense, nothing against neural networks. I'm a big fan of them as well, but they are not always the most fitting ones. Yeah. And so sometimes it can happen, especially when we talk into the business, that we decide for a random forest algorithm, because the business feels more that they can understand what is going on in such a random forest algorithm. They can see the influences better. And such a neural network, first of all, doesn't fit that well to the data that we have. And then also would be just a black box for them. Yeah. So I have these discussions all the time. Yeah. But I think it's always great that we get challenged with the algorithms. Yeah. But it's always good that we then discuss about it and make the best decision for everyone.
Okay, thank you. Sorry, we just drifted away from the original question, but just because you mentioned, Karthik, what is kind of like your approach, how to make sure that developers and business users work?
Absolutely. So in general, I would say that the dev team should know some parts of the business that they are actually working with. For example, on the service that they are working, for example, the dev team should know probably some parts of it, or hopefully, the ideal case would be all of it. But in general, you cannot know about all of the businesses, all the 100% of it, and the other way around as well. Businesses should also learn about something about data science and something about machine learning, because that will keep expectations at check. So they cannot expect everything to be solved by machine learning, for instance. And this is where, like Sarah mentioned, the translator, you have to make sure that the dev team is also clear, the businesses are also clear about what they can expect from a machine learning service or any machine learning algorithm. And this is I've been a part of both sides. And just like Sarah mentioned, yes, so the dev team generally, the feature maps are generally also business driven, for instance. And in general, there is no point in having the latest and the greatest if nobody's going to use it, right? So I completely agree with Sarah on that part. We also generally prioritize our features based on what the businesses actually want. So as soon as we actually have like a consensus from a few business users about what exactly are their problems, and we have n number of business users having the same problem, then we build this feature. And we have to also adhere to different product standards. So in that sense, we cannot generally, just like that, go to the latest and greatest, because, we have to be clear on all the fronts. So not just in terms of the machine learning parts, but also make sure that we have latency requirements. We have all of these, satisfied, to make sure that the service is actually competent enough to, make sure that the customer can actually use it in an actual business application.
Thank you, Karthik. Andreas, anything from your side with regards of developers, business users working together on data science projects?
Yeah, I would just add maybe one or two points, because it's also valid what Sarah and Karthik said, where sort of sometimes it might happen that maybe a company wants to be more innovative, want to be more digital, more data driven. And I've had cases where I was given a data set, and then Andreas, no, please do some machine learning on it and make our business better. And that's just not how it works, where I wish it would, but you need to spend the time, and that is with time with the business, to understand that business, to understand the challenges, to then come up, with approaches that will hopefully help. And then it's really just the next step. What data is available? Can I use it? How can I access it? How can I prepare it? But that initial phase is so important. And once sort of things become clearer, or maybe actually to add, well, often companies might not know exactly what could help, and for that, often we run data value workshops where we sit down with the customer, we show a few examples of what we've done, try to stimulate ideas, and then go through like a creative process where we try to collect possible solutions, approaches, and then we prioritize and decide on something where we might go into a proof of concept. So that can then help get the business on board and on something very relevant and realistic. But even then, while things are being implemented, and whether it's a proof of concept or whether it's really already productive, it's still really important to stay close to the business, to keep them informed of what you're doing. On one hand, to keep them involved and to help that acceptance of what you're developing. We can't just disappear for a while and then come back and, oh, here's the solution for the problem we spoke about some time ago. But you have to be close, you have to be aligned. They'll have fantastic input on what you're implementing. They give you very good sort of feedback on how to do it right. But because they're also involved, it helps the adoption that the components actually will be used. Sarah said it, the most fantastic model, it has no value if nobody's using it, and nobody's using it. It might be a transaction somewhere that nobody opens because they don't know what it does, what it means, they don't trust it. So providing that trust, is really helped by collaborating, not just point to point, but ideally throughout the whole process.
But isn't it that data science or machine learning or AI is such a hype right now that like business expectations are just simply unrealistic in when you are facing customers, like where they're throwing a lot of money on that and they just like expect that it will do something, I don't know, unreal. Have you faced any situations like this?
There is a danger because yes, it is a big hype, and personally, actually, so I try to use the term machine learning rather than artificial intelligence, because this artificial intelligence is part of that hype, in my personal belief. Okay. I find it very hard to find really different definitions for machine learning or AI. Is it deep learning? Is it unstructured data? At the end, I think in simple terms, it comes down to algorithm and math, and so machine learning, I find sort of a more suitable term, at least for what I'm doing. And it's maybe that it was that example of here's a data set, now tell us something, then, well, let's do it together to have something that's really meaningful and helpful. Yeah.
Okay. And one thing that you mentioned a couple of times was kind of like data. So what are the most common issues, like, when you start, let's say this, or like in general, even not starting, but during the project, machine learning project, and when you're dealing with data, is it volume? Is it quality? Is it something else?
It could be either. It could literally be anything, because you really never know what's coming. And maybe going back to that example of the chemical manufacturer, where we want to join sensor data from the manufacturing plants with ERP data, because so far we don't quite know yet how the data will arrive in our place. The sensor data, for sure, it will have a timestamp, but what is that timestamp? Is it Unix? Is it integer? Is it really like a sort of, is it a clear date? Simple things like that, where but you really have to be specific to match not just on the date, but really on the hour, or even more granular. Like the machine at that moment, the sensor data, was the machine really producing batches, that then you want to sell, or was the machine still warming up, or was it in a cool down phase? Because these phases, you have to know what is the machine currently doing. And that information is part of the ERP. So that means now we have to match it. And like missing data, always a challenge, but there are approaches that can deal with missing data. And that is also part of that sort of highly automated approach with machine learning of what can be done, where it's often not the best model that you need, but you need a big number of very good models. Sarah, I think, touched on it, where here, if you want to automate something, that automation has to be able to deal with these unusual things, or at least things that a data scientist manually would have to do themselves, and that can deal with outliers, very unusual values, big or small, can deal with missing data. So very often, this automated approach is the first step to see, is there a pattern in the data? How clear is it? Do I have a model? Is it good enough to provide the value that I need? Fantastic. Or does it really require that more manual step of literally doing all the steps manually, all the data science steps to create the best possible model for that very use case? So you never know what's coming would be my response.
Actually, while you were describing all these issues, I was already willing to drop anything and just go and start working with some data. Yeah, I love it as well. Sarah, what are the most common issues dealing with data that you are facing?
Yeah, I can only agree with Andreas. It's always a surprise. What's for me always a challenge is that we don't have enough historical data. Yeah, because it's pretty hard to, for example, do predictive planning. Yeah, for the next year if you only have data from the past half year. Yeah, that's then pretty tough. Yeah, or sometimes you don't have enough labeled data. Yeah, because when you want to predict something, you have also to learn from the historic data. So you need to know what happened in the past. Yeah, and when you then have any data which is labeled for your algorithm to learn from, then this is also pretty challenging, depending what you want to do. Yeah.
Thank you, Karthik.
Yeah, so I think this is I can add to exactly. I'll add to Andreas and Sarah's points here. One of the things that I usually find, probably also miscommunication also, from both sides is basically people assume that the number of instances of training data is equal to the better quality. So this is something that I constantly encounter whenever the topic of deep learning comes in. The question is also like generally the data science teams generally say, oh yeah, the more data, better. And businesses don't understand that literally just, having 100,000 records does not mean it's better data. You could still have 10,000 very well, labeled, very well, properly available good data sets as well. But the question is also, people also assume just because you said you need 10,000 instances of this data, what business users also do is they copy paste the data. And this is something that I find a bit of miscommunication from usually the data science teams. Also, of course, there is also partly media also to not to blame, but rather media hype is also there. So basically, where business users read, the more the data that we have, the better the algorithm is going to learn. Yes, that's partly true, but that does not mean that you copy paste this data to get more data. So this is where I think this is one of the biggest challenge that I actually find, not so convincing users to understand what does data quality actually mean for them, and then also to convince them that you need to have better data sets in terms of the labeling, in terms of just like you mentioned about how you handle bias, in terms of the quality as such, having as many probably historic information as available as Sarah rightly mentioned right now. So all of this actually contributes to the final quality of the data that you're dealing with, and not just copy pasting it. And in general, I highly recommend people not to copy data. Just if you want more data, that's not going to be the solution, because mathematically you're adding no information to the model to actually learn from. So that is something that I have to constantly deal with and constantly explain to people on a pretty much like a weekly basis.
Yeah, include this session into your weekly basis now as well. Thank you for explaining this to me. So you like teach machines, right? How to do machine learning, but how do you as persons learn yourself? Like, what is your process to keep up to date with your knowledge? Karthik, maybe we can just continue with you.
Sure, yeah. In general, what I do is I try to make my learning as fun as possible. So usually, so for instance, I wanted to learn about GAN, so generative adversarial networks. There is a very cool specialization on Coursera where you could actually stylize your images and stylize like cartoons and things like that. So generally, having fun when learning is a great booster to actually complete the course. Because usually what happens is you are really, really excited to sign up for a course. A lot of the times I feel that I've never completed the course purely because after some point, the excitement is lost and then I have no will to finish the course. And I found that generally having a lot of fun in learning something new, and especially doing something that's not necessarily related to work, but rather something to do with, say, for example, music, and then also creating something cool with maybe like a computer is also a really cool way to also learn about the basic like mathematics and how you deal with audio, for example. But generally having fun when learning seems to be a great motivation for me to learn about new concepts.
And just because you mentioned, this Coursera course, actually, I do consider myself more of the data engineer, data analyst than data science. And I'm just learning machine learning to understand to the extent where it kind of like makes my job and my work more meaningful, and where I do understand what is required. So I'm doing this Coursera course on machine learning with Andrew and G right now, and just to keep myself motivated, I just paid for this course. So there was possibility to take it for free, but I knew that if I pay, then I will stick to that. So this is how I keep myself motivated. So
that's
Sarah,
another motivation.
Sarah, how do you learn when you are not teaching machines?
I actually learn a lot from my students. Yeah, I work closely together with students, and I'm supervising their bachelor and master's theses. And I always encourage them to come up with some crazy ideas and pick their own topics and what they want to do. And this way, I also have to keep up with them. Yeah, so I also have to learn a lot new things. I probably learn as much from them as they learn from me. Yeah, maybe I learn a bit more. Yeah, and this is always a lot of fun. Yeah, to work with the young, motivated colleagues here. Yeah, support them, learn from them, try new things, try maybe some new and crazy things, and it is pretty cool. Yeah.
Cool. Which university are you teaching at?
It's not a specific university. I'm also sometimes giving courses at some universities. Yeah, whenever they ask me. Yeah, and I'm also supervising. Yeah, sometimes from Mannheim University, sometimes from our I'm not sure how the English word for it is. Duale Hochschule. So it's sometimes they're coming from the University at Darmstadt. So it's a pretty diverse set. Yeah, I also have one from Berlin, which I'm supervising. Wow. One from Vienna. So yeah.
Okay. So it is a little bit broader than just a local university. I'm actually sometimes teach here at local university, and I found as well that preparing myself to teach others is one of the best ways for me to learn. Andreas, what is your approach, or what are your techniques to stay up to date?
Yeah, there was all really good tips you had on enabling and learning, and I guess I do a bit of a mix of a few things that you mentioned, like so the fun part that Karthik mentioned. So for me, when I started out in machine learning, and Vitaly, you said that there's a lot of people on the audience who don't consider themselves data scientists, so maybe there's a question how to get started. And so I found it, well, at first, it seems this intimidating topic, machine learning, data science, where do you start? But really it turns out you can start with very simple steps that are already extremely helpful. And I found it most useful to work on topics where maybe I knew the topic, I knew the data. And one fun topic I was working on was music recommendation engine, where there's university in Vienna, actually, where they collect data on people's listening habits. And then you can use that data to come up with a little recommendation engine. It was just a learning exercise for me, but it was a fun topic, and you could enter your preferred bands and would output other bands, where it just seemed to make sense for me. It was useful. And on actual sort of learning outside SAP, is really the online courses. Andrew Nook is one course where I'm enrolled in on ML operations. I just haven't logged on very recently, I have to admit, just haven't had the time, because of the other topic, I guess, where I'm learning. And that's just the projects where we're on sort of day to day, where very often, so like for new topics, for new areas, there's new skills required. There's always something new coming up, or because it's a new area of data, of business that you're working on, that there's always more to learn, more components, different engines. So a lot of my learning almost is a byproduct of doing projects without putting time aside. But I know that to make that a good project, these are the things I have to learn. And then often it just happens on the go, because that works best for me. So I can't really just read something and try to memorize it. It doesn't quite work. If I do it myself, if I implement something, if I see what goes wrong, if I see what works, this is really what settles best for me. So these things tend to stick. And because once I know how something works, now I have to write it down anyhow, so I remember for next time. And sometimes I just tend to put that into a blog, put it on the SAP community, and I'm actually going back to my blogs myself to remember what was it that I did to make it work. Because very often that learning is just not well, teaching, it's not just teaching, but it's also learning for yourself, because once you put it on paper, you really want to make sure you describe it right, it's correct, and you have to invest then more time in it. And then also, it tends to stick better in my mind.
It's interesting you mentioned going back to your own blog posts just to refresh your memory. I do the same. Yeah, it's just that I checked recently. I have like 157 blog posts on SAP community. So sometimes already finding just like what I knew is becoming a little bit of the issue. And continuing on the topic of education, so in 2 weeks, SAP Ticket is coming. This year, it is again global virtual free event available for everyone to join. Are there any specific sessions or speakers that you are looking towards? Are you maybe presenting yourself any sessions, Andreas?
So this year, I'm not presenting anything myself, but sort of I picked out 2 Ticket sessions that I wanted to mention. First one is on Tuesday, November 16, which is on is deliver hyper automation with artificial intelligence technologies from SAP. So a session really combining different components from the business technology platform to sort of really derive a very comprehensive solution. And the other one on Thursday, November 18, powered through one-to-one personalization with AI. And this is an immersive session. So there's not about creating machine learning models necessarily ourselves, but it's machine learning embedded in a standard application, immersive. So a takeover SAP did in the area of customer analytics. And so for me, it's also very important to know what is already coming as part of the standard applications, so that, because there's no point doing machine learning for the point of it. It has to go into a business process. So we always have to know what is part of the standard applications. And lastly, anything around data intelligence is, in my point of view, always helpful to look at.
Sure.
My sessions.
Karthik, what are your choices? And I believe that you are actually one of the speakers, right?
Yes, that's correct. So my choices,
feel free to promote your session. No problem.
Absolutely.
With that at all.
So we have 2 AI business services workshops on the 17th. Basically, the first session is from document information extraction, where I will be holding a workshop on how do you create schemas and how do you also use templates to actually extract information from documents in a business context. There's one more workshop by my colleagues as well. So basically, this is on data attribute recommendation. This is again on the 17th. This is on the afternoon at 2 o'clock CET. It's called Apply Machine Learning and Regression Models to Classify Data Records. So these are 2 things that are close to home. But more interestingly, I'm also really interested to actually listen to improve developers' lives. So this is a developer keynote. Yes. And this is at 5 o'clock. So this is, I think, something that I'm really looking forward to. And there is also one more in terms of the AI Core and AI Launchpad. Like I said before, it's at on November 16th at 9 o'clock CET time zone. So if you're interested in also getting to know that's a type of a lecture, but it's not hands-on. But yeah, that should be really interesting for you as well.
And just full disclosure, our developer advocacy team is the one in charge of the developer keynote, and I didn't pay Karthik to mention this session at all. So thank you for looking forward to that. Sarah, what are your choices?
Yeah, I see it like Andreas. So everything regarding data intelligence is pretty cool. For data intelligence, I have 2 things which I found particularly interesting. The one is integrate SAP S/4HANA with data intelligence, and that's a deep dive and hands-on session that actually runs twice on Wednesday and Thursday. And there's a second one for data intelligence, which is create and manage data flows using SAP Data Intelligence. And it also runs twice on Wednesday and on Thursday. And even though these ones might be booked, I didn't check if they're fully booked, but especially for the hands-on, there will be a GitHub repository available afterwards where you can get also the material and the code. And this is something I always feel pretty helpful, that you already get some code snippets, which then help you when using the tool on your own. And besides data intelligence, I also find it pretty interesting. There's one session about our new Kuma runtime on the business technology platform. It's called Manage Your Kubernetes-based extension for SAP applications. I'm really looking forward to that one because I myself am a big fan of Kuma. Yeah, because now I can finally put my R code into production on our business technology platform, which is something which was not which was not available for the other runtimes. Yeah, so I'm really looking forward to that one.
Okay, so Andreas mentioned Python, you mentioned R. Karthik, Python or R?
I would say most likely Python, but I don't have a preference.
Okay, we are almost at the end, but there is just like, if you don't mind, a few more minutes. I just really wanted to ask Sarah while we are on the topic of events about the SAP Analytics Hackathon, SAP Analytics Cloud Hackathon that you were running, I believe, for the second year already. So how was that experience and what are the plans for this SAC hackathons for the future?
So the hackathons are always my highlight of the year. Yeah, I really love hackathons. That's why I'm organizing so many. And for SAP Analytics Cloud, we also have big plans for next year. This year, we've been running 5 events, and next year we are also planning for at least 3 events. We hope that we will have 2 virtually and 1 on-site event. I hope we can make at least 1 on-site event. I keep my fingers crossed. Yeah, but if it's not possible on-site, then we will just have more virtual events, which also works pretty well. I'm really looking forward to that. Yeah.
And where do people can find information about these hackathons if they are looking for?
So on our SAP community, I will always write a blog post about it. Yeah, when the next events are coming up, and I will also post it on LinkedIn. Yeah, so you can also just contact me, and of course we will invite you. Yeah, and maybe you can also mention it again in your developer news. Yeah.
Of course. I hope that I mentioned these hackathons in the past in our developer news. And for those who listened to us live, thank you for joining. Thank you, Andreas, Sarah, Karthik, for joining as well. Time flies when the discussion is great, but we are at the end of our hour. So thank you a lot.
Thank you.
Thank you very much.
Thank you.
Okay, bye.
Bye, everyone.
Bye.